leaves. So if you have those or can get those by the end of the presentation, that would be great, because we're going to try to do a little bit of walking through dichotomous keys together. It's a great tool to know for identifying trees. I will also say real quickly, if you hear any noises, it might be my kiddo or my cats. So I'm sitting in my kitchen because my office got a little too hot. So I'm going to pull up a PowerPoint and share the screen. And give me just a second to do that. Okay. All right. All right, so I am hoping that everybody can see that. If I hear no complaint, can you see that, Betty? Everybody? Yeah, great. Okay. All right, so we're just going to start with basic tree ID. And I do this presentation a lot for master naturalists, tree stewards, sometimes general public. And so the first thing we do want to know is, why do you need to learn to identify trees? It's important to know things about your site. If you are if you've bought a new house or have a new property, knowing what trees are there can actually tell you a lot about the soil. It can tell you about other site conditions, such as how much light or maybe moisture regimes and all sorts of other site characteristics. Also, we like to know about providing for the needs of wildlife. So if we have an idea of what trees we have and what benefits they have for wildlife, then we can make sure we keep the trees we want or add trees that we are missing. Identifying trees also helps us improve the conditions for other plants, because there are some plants that prefer to grow under in a forest understory or under particular trees. And so that helps us too with any sort of planting or management we might be doing. Some people want to identify trees because they're growing them for products. They're going to harvest them and use them. And so different trees do different things. And knowing what you have helps you know what value you have, helps you to hook into markets and know when is the best time that you might want to harvest and what you might want to replant. Also, for trees that are being planted in your yard or in a field setting, understanding something about the trees the identity of the trees helps you know a little bit about the needs of the trees, where you should place them, what kind of care they'll need. Will they get too big if growing beside the house or the driveway? Should they not be planted near your septic system? Things like that. Also, identifying trees can help you identify the ones that should not be there. We have a lot of invasive species issues here in Virginia, particularly for those of you like me who are in Central Virginia. And I know your membership might go farther west as well and maybe cover the whole state. I don't know. So we have the whole state has invasive species issues, but I always say here in Charlottesville, we're at ground zero for invasives, probably because some of our founding fathers love to bring in things from other countries. And we've all experienced trees and other shrubs and things that we don't want. Also, I like to identify trees because it's cool to know stuff. I think it's just great to be able to walk through the woods and just know what I'm looking at. Just kind of helps me know my place in the world. And if you've got nerdy friends like I do sometimes, you can show off to them by identifying the trees. So this seems like one of those duh questions. What is a tree? But I put this up here because there is some overlap between what is considered a tree and a shrub. So a tree is a woody plant, but so is a shrub. Usually a tree has one main stem. Usually shrubs have multiple stems. So again, I'm not saying always, I'm saying usually. The mature size of a tree is usually more than 15 feet tall and usually more than 3 inches in diameter, stem diameter. There are some mature shrubs that will fit this criteria, but really what you need to know is the tree versus shrub debate is not really that important in terms of dendrology or botany. It's really more of something that we have constructed as humans to determine how big and how wide and where we should plant this particular species. So woody plants are kind of all classified in the study of dendrology. So you might see some trees and some shrubs and some things that fall in between. Whoops. Okay, so we're going to launch right into identification features. I'll go over these one by one. Easiest one is leaves. Whenever I do tree walks, I like to do them in spring and summer and fall because the leaves are on, and it makes it a lot easier for people to learn to identify them. There's also bark, and that's really helpful in the winter, but a lot of people like to learn the bark in tandem with the leaves so that they can kind of get an idea of the total picture of the tree. Twigs are super important in the winter. I often do winter tree walks, and we look exclusively at bark and twigs and maybe remnants of other things that might be on the tree. But twigs have their own special features, and I will go over those tonight as well. Even though we're in leaf season now, and it's the easy season for identifying. Reproductive parts are also important for tree ID. That would include both flowers and the eventual fruit of the tree or nut, whatever type of fruit the tree might have. The overall form, shape of the tree is important also. Some trees have a characteristic shape when they're viewed from a distance. And so looking across the landscape, you can sometimes tell what you're looking at just by that. Also, the growing site is important. If you're walking through it's not important if you've planted a tree, because you could plant a tree anywhere. It may or may not do well on certain growing sites. But if you are walking through a forest, looking at the types of trees that are there can tell you a lot about what type of site you have. Is it wet? Is it dry? Is it is it getting a lot of light? Is it a fairly new site, newly treed site? So these are all features. Sometimes there are others as well. Could you guys excuse me for a second? My daughter is cooking something and it's boiling over. I am so sorry. You guys have kids, you know how it is. Okay, so all right, so let's look at, my screen has locked up here. Am I still sharing? Okay, for some reason, my page up and page down is not working anymore. All right, I am locked up. Let me see if I can jump out of this. There we go. Okay, great. All right, here we are. All right, so since I said leaves are the easiest to identify, we're going to look at some leaf characteristics, and then we'll look at some actual photos, and I'll actually hold up some leaves as well. So when we're looking at leaves, we want to know whether they are deciduous or evergreen. Deciduous means they fall off in the fall. Evergreen means they stay on all fall. And evergreens are not all conifers, and they're not all needled. There are some broadleafed evergreens as well. In addition, there are a few deciduous conifers. Bald cypress being the main one that we think of as our native that actually sheds its needles every fall. We have to look at, when we're looking at leaf characteristics, the arrangement of the leaves on the stem. We will go over that in detail in just a minute. We want to know whether leaves are simple or compound. We'll also go over that. We want to look at leaflets. If we have a compound leaf, we might want to look at veins for any leaf, but particularly simple leaves. And we can tell by looking at them whether they are pinnate or palmate. I know these are all new words I'm throwing out at you, but I'm just going to overview them right now, and then we'll look at some details of what those things mean. The margins of the leaves are the edges, and we also want to look at those. They have different characteristics as well. And then the base of the leaf, where it joins the petiole, and also the tip of the leaf can also be very distinctive depending on what species you're looking at. Finally, for leaves, we have special characteristics. These are always my favorite to teach when I'm in person, because we can scratch and sniff when we pass them around, feel the texture, look for special glands that might be on the underside. Smell is a really cool thing to know to impress your friends. If you know of a tree that has really particularly nice smelling leaves, that's something that you can share. Okay, so let's look at leaf parts, and this will start to get into some of those terms that I've been using. First of all, the main part of the leaf, the flat, broad part, is called the blade. And the little stem that attaches the blade to a twig is called the petiole. This is slightly different in compound leaves, and we'll look at that in a minute. But the edges of the edges of the leaves are called margins, technically. The book that we have in forestry, we call them edges because we work with kids a lot. And sometimes using words like margin that might not be familiar we would prefer to use something that is user-friendly. It really doesn't matter what you call it as long as you know where you're looking. And then the veins in the leaf are usually going to be sort of impressed. You can see them from the top and the bottom of the leaf. Some species you can see them better from the top and some better from the bottom. In this case, the veins are pinnate, and so I will go over that as well. Okay, so let's go in depth on leaf arrangement. Alternate leaves are what mostly you will see in our native landscape. Alternate just means that the leaves are attached in an alternating fashion with each other, sort of zigzagging along the stem. And opposite leaves are attached directly across from each other. So if you look at this picture, you can see the difference that the alternate has only one leaf per node being a point of leaf attachment, and an opposite leaves having two leaf attachments per node. There are a few species, not really our natives, but there are a few exotic species that have whorled leaves. I didn't put that up there because you're really not going to see it much in the landscape, but it just means there are more than two leaf attachments at a node. Simple versus compound leaves is a feature. It's usually one of the first features you have to identify when you're using a dichotomous key, as we'll see later. But a simple leaf has one part. Doesn't matter what shape that part is, doesn't matter how complicated the appearance of it is. If it has one blade, it's a simple leaf. If it has multiple parts to it, we call those leaflets, and that's a compound leaf. So the leaf you see at the bottom is actually only one leaf. It looks like 7, but it's 1. And the way you tell the difference between, this is the thing I get asked a lot in the field, how do you tell that you're looking at a compound leaf or you're looking at simple leaves that are oppositely attached to each other. And the difference is that the leaf stem for a compound leaf, which is called a rachis, it has a different name than petiole, but it's really the same thing. That leaf stem is going to be flexible. And so it's very bendy. It's not like a hard woody twig. It's going to be fairly flexible. Often it's green, but not always. So that's not characteristic. But it will be flexible. And where it attaches to the stem, there will be a bud right above where that point of leaf attachment is. And that'll be where next year's growth will occur. At the base of the leaflets, which are just parts of the compound leaf, you don't have buds, because that whole thing, all 7 of those leaflets plus its little stem, the whole thing will fall off in the fall. So that deciduous leaf the whole thing is gonna fall, and there won't be buds left on that leaf stem for next year. Let's talk a little more about venation or vein arrangement. So the leaf at the top here has a pinnate venation, and that means there's one main vein that starts at the petiole and runs most of the way to the end. And off of that main vein, there will be lots of other branching veins. They all kind of look like a river system to me if you've ever looked at like a map with rivers on it. But if you picture a pinnate one is like a big river, like the Mississippi, with lots of smaller rivers feeding into it. So the difference between that and palmate, if you think palmate, think palm of your hand. You have several main veins that start at the petiole and go out toward the end, and you can't tell really which one is the main vein the way you can with the pinnately veined leaf. So in the case of the leaf at the bottom here, I can see 1, 2, 3, 4, 5 main veins that all have other veins branching off of them, just like in the pinnate example. But you can't determine which one is the main vein. There are 5, and they all originate right there at that point at the base of the petiole. When we're identifying leaves, we are often presented with the term lobes. Lobes and sinuses are opposite each other. I always tell people a lobe is kind of like your earlobe. It's a part that sticks off the main part of the leaf. It's kind of separate, and a sinus is the kind of the hole or the gap between the lobes. So a lobed leaf is going to look have sort of an in and out edge to it, regardless of whether or not it has a serrated edge or not. So let's look at those edges or margins. Those can be very different as well. The picture on the right is what's called an entire margin. That just means it's smooth. It has no teeth, no nothing. Just a smooth edge all the way around. The picture at the top, you have to look really carefully at it. You're probably looking at this on your computer like I am, and you're seeing, if you look real carefully, very, very fine teeth on that leaf at the top left. And that is a serrate margin. If you look at the bottom leaf, bottom left, that's considered doubly serrate. I like to say this is like a saw blade where you have large teeth with small teeth on them. So there are teeth on the teeth if it's doubly serrate. If it's just serrate, they're just very even little teeth all along the edges. Some of our trees don't have leaves per se, they have needles. And looking at how those needles are put together or how they're attached can be very important. On the top right, you'll see pine needles that are in little bundles. And in the hand below on the bottom right, you'll see what's called a fascicle of leaves. A fascicle being the little sort of flaky part that holds those needles together in a bundle. And so different trees have different numbers of leaves or needles per fascicle, if they have fascicles at all. Sometimes they don't. If you look at the picture on the left, that just has single needles. And in the case of this one, often the juvenile foliage, which is what we're seeing here, looks like needles. But as the foliage gets older, those needles lie down and press forward on the stem, and they'll actually look like little scales. So they might actually be oppressed so tightly to the stem that they're like a snake's scales. And you'd have to pry up the edges to see that they're actually needles. Okay, now this is where it's going to get tricky because we have a lot of people on this call. So I'm having somebody monitor the chat, but I want you to put into the chat, and Betty is going to share with us some of the things you say. Given the terms that we've talked about, tell me what characteristics you would use to describe this leaf. And you can just type in, one thing. I'm not monitoring the chat, so we're going to get a kind of a synopsis from one of our chat monitors here.
Okay, we have someone has observed that it's palmate.
Okay. Oh, and I'm glad somebody observed that, because this is a tricky one. This one, it looks like it would be palmate based on the way the lobes are. But if you look, you will see there's really one main vein. It's a tricky one because a couple of those veins, they kind of peter out. They look like they're going to be main, but they're much thinner. And this one is one that looks like it would be palmate and is actually pinnately veined. We'll see some other examples where it's a better example of pinnate venation, and we'll see a palmate one as well, so you can compare the difference. But I always throw this up there because it is tricky, and this is a fairly primitive tree. The family it's in is the magnolia family, and it is those are fairly primitive, and that may explain why it developed the shape of a palmate leaf, but the venation of a pinnate leaf. So good observation, and I can see why you would say it. So let's get some of the other characteristics.
Okay,
what
so
else
a lot of people have pointed out that it's simple.
Yes, exactly.
People have looked at the margin and have seen that it's smooth margin.
Yep. Entire and smooth. Yep.
There are some people that said pinnate.
Okay, yep.
People have pointed out that there are lobes.
Yes. Very good.
I think
you got most of the main characteristics there. So that is great. And we're probably going to look at at this leaf a little later. In person, sort of. I'm going to hold up a twig and we're going to key it out, so I won't tell you what it is yet. Some of you probably know. Okay, how about characteristics of this one? Go ahead and type them in the chat. This is one of those leaves where if somebody told you to draw a leaf, that's probably what you would draw. Whenever I identify this species in the field for people, I tell them there's not a lot to describe about this leaf. It is the generic leaf.
So people are pointing out that it is simple.
Yep.
That it is entire.
Yep.
Someone has pointed out that it is green.
Yeah. It is.
What else do we have here?
Although it turns a really beautiful red in the fall, very early in the fall. This one's also, if no one's gotten it yet, this one is definitely pinnately veined. You can see the one main vein that goes almost to the end, and
yes,
all the other ones shooting off of that.
Yeah.
Okay, good. All right, let's do another one. That was a really easy one. How about this one?
Okay, people are pointing out the lobes.
Yes,
That it's
yay,
lobes.
good.
Simple, pinnate, smooth edges.
See, I'm sorry, didn't mean to.
Oh no.
Didn't mean to do that.
Yeah, simple lobed, smooth edges, pinnate. Let's see, I'm trying to make sure I didn't miss anything. Someone has identified it, but I don't know if that's a spoiler alert or not.
Don't do that, guys. Well, you can if you want to.
I won't read it out loud, but people may be reading it in the chat, but I
That's
won't read it out loud. But I think, yeah, that's what we've got.
all right. So here's another one. This is one leaf. That's your big hint.
Compound.
Compound, thank you. Yes, so this is a compound leaf. And to identify other characteristics, you have to look at the leaflets. So you can say that it is pinnately compound because not just the venation can be pinnate, but also the way it is compound. Most of our compound leaves that you'll see in the woods are going to be pinnately compound. There are a few palmates. The one that comes to mind is buckeye, yellow buckeye. If you've got one of those on your property, you'll see some palmate leaflets in a compound leaf, meaning, and that just means that all those leaflets are originating from one point on that leaf stem. So think of the way palmate veins looked, and that's the way a palmately compound leaf would look. But this one is definitely pinnately compound. Can you see the margins?
People are looking at the margins and they're noticing that they're at least serrate, if not double serrate, which is the resolution of at least my screen. I can't tell.
Yes, and if you had it in front of you, you can see it more easily. It is definitely just serrate or toothed, which is the word I use for kids. They know what teeth look like. They may not know the word serrate, and so. Yeah, let's switch to one more here, and then we'll go on to a few other basics.
Palmate.
Yes, see those three major veins? You can really see them in this species. There's palmate, and I'm curious to see what you say about lobes and margins.
So people are saying that it is in fact lobed.
Yes, I would say so.
Simple. People are noticing it's simple. People are saying that it's serrate.
It is, but those serrations are really widely spaced, right? So they look a lot different than the last serrated ones we saw. This one usually is described as having very widely spaced teeth. So you can kind of see how that's true. All right. Oh, well, we might as well do this one. What do you notice about this one? I might point out a few extra features here.
Double serrate or ragged.
It is doubly serrate, yes.
Simple, pinnate.
Yep.
Double serrate.
Yep, got all that. Exactly. A couple of things I'll point out about this particular leaf is that this is one where you can look at the base of the leaf, and it's very sort of wedge shaped, the way the two halves of the leaf come together at the petiole. And this one also has very parallel side veins. You can see it's almost like somebody drew them in a line, straight line out to the edge. So some characteristics we didn't go over in specificity, but that might be something that you would get when you went more deeply into a key or a field guide. All right, let's move on to some bark characteristics.
We have one question first.
Oh, sure.
Are all subspecies of a major species, for example, maple, all palmate or all pinnate?
Okay, so well, all species of, okay, so let's talk about the difference between species and subspecies, because maple is a genus. So that is, that's your broad, it's the genus Acer. So it includes, red maple, silver maple, striped maple, mountain maple, black maple, sugar maple, all sorts of maples. And so each of those ones I named is actually a separate species. And then when you get into subspecies, the subspecies is usually going to look, most people don't really delineate most of those as subspecies. You might have some subspecies of, say, red maple. It's going to be, Acer rubrum with something else after it, with VAR and something else after it, if it's a subspecies. In the case of subspecies, they would be the same as the regular species. But in the case of separate species, like, for example, box elder is a maple. It's in the genus Acer, but it has a compound leaf and looks very different from other maple leaves. So in general, people talk about, when they talk about maple, you picture something in your head. You picture the Canadian flag, right? I mean, it's something, it's a general mapley looking leaf, and that's true for most maples, but clearly not all, because box elder is one exception that is different, is in the maple genus, but is differently shaped. So hopefully that answers the question. Okay, so we're going to quickly go into bark. We're not going to spend a lot of time on it. We're going to mostly look at leaves tonight. But bark characteristics, the terminology is subjective. I tell everybody that I do classes for that you come up with your descriptive terms that work for you. So they're kind of non-technical, smooth, scaly, ridged, furrowed, fissured, platy, blocky, netted. All of those are kind of, they're descriptive words, and what looks one way to you might not look the same to another. So I just tell people, you come up with, when you learn a tree, look at that bark and decide what it looks like to you. You can read what the field guide says, but if you like fissured better than furrowed, or if you like ridged, or something like that, then you use that word to help you remember that bark. So I'll put this up as an example. How would you describe, and there is no right or wrong answer to this, how would you describe this bark? Type it in the chat if you want to, throw out a descriptive term, and we'll see what people say.
We've got a smooth.
Mm-hmm.
Smooth with gashes.
Yeah, I like that. See, that's great. I like the way it is smooth, but it does have gashes. It has some rough areas, some little, I like that. I'm going to use that. It does sort of look like it has gashes. So, yeah. So
someone else says semi-smooth.
Semi-smooth.
Scarred. A couple of people say scarred and smooth.
I like that too. Yeah.
Someone has keyed in on the color, but it's gray.
Yep. And bark color can be, they're not all gray and brown. Sometimes they're almost black. Sometimes they're different colors. So color is a key, is a characteristic. How about that one? How would you describe this one? And it can be multiple words.
Yeah, we've got a lot of scalies, a chunky.
I like chunky. Yeah, I haven't heard that one before. That's
rugged,
good.
Blocky, thick, rough.
Yes, all of the above. Yes.
Rough and scaly.
Okay, good. Yeah, scaly blocks and all sorts of possibilities. How about this one?
Netted.
Kind of netted, or some people like to call it interlaced, or diamond pattern.
Diamond fissured, furrowed.
Yep.
Deep grooves.
I like that. Okay. So yeah, you guys are using great powers of observation here. All right. So that's just keep in mind, bark is subjective. Leaves have, there's some terminology, but bark is probably going to have less terminology. It's just going to be more subjective. So lastly, we'll look a little bit at twig characteristics. This is not the time of year to be looking at twigs because having to pull all the leaves off actually sort of changes some of the features, and you won't really see a terminal bud or lateral buds this time of year because those buds things have expanded out, it's growing. You won't be able to use these characteristics, but keep them in mind for winter. So the terminal bud or the end bud is the last bud on the twig, the one at the farthest out from the trunk. And that is often shaped a little differently than the lateral or side buds. And near those buds are going to be leaf scars. So a leaf scar is where that leaf was attached before it fell off in the fall. And inside that leaf scar, you might be able to see bundle scars, and that's where the actual vein tissue, the vascular tissue went into the twig, from the leaf. And that will have specific patterns in some species that are really easily identifiable. As you might guess, it is super important in the winter to use a hand lens so that you can actually see some of these features. I mean, if you have middle-aged vision like me, you might need the hand lens. Even, younger people can benefit from that as well. This particular twig has a solid pith, and the pith is the inside of the twig. In order to really see the pith, you have to sort of take a blade or a knife or a razor blade or something and slit that twig longitudinally so that you can see it. I never look at pith because I'm a little bit accident prone, and trying to cut a twig in that way is danger for me. So I usually try to use other characteristics, but if you like to look at pith, some of them are really interesting. Some have a solid pith, some have a spongy pith, some have little diaphragms in the, dividing the sponginess. Some have hollow pith, some have chambers, little hollow chambers along the pith. So it's kind of neat to look at, but just be careful with whatever blade you're using. This twig also has lenticels, which are like little pores for gas exchange. They look like little dots. Some species have them very easily visible and some don't. So as you can see, there are different things you can look at on a twig versus looking at leaves. Notice though that the leaf scars are going to be arranged in whatever way the leaves were. So you can tell if it was an alternate arrangement or opposite. In this case, alternate, because you've got one leaf scar at each node. So some tools you might need when you're identifying trees. Your senses are the best. What does it look like? What does it feel like? Sometimes, what does it smell like? A dichotomous key is really important. We're going to go over that in just a minute. It saves you a lot of flipping through the field guide. Field guides are great for once you've figured out what the leaf is or the tree is, then you can open up the field guide to that species and read about it and verify your identification. But sometimes, if you're new to ID, just taking a chunky field guide and flipping through it until you find the tree that you're looking for can take a lot of time. A key is a systematic way of going about it. A hand lens is really important for those little details. And you can, clippers or a knife. Sometimes I just like to have clippers with me because if I'm not sure what something is, I can clip it and take it home, a bit of it home, and look it up there where I might have more resources. Practice it doesn't make perfect, it makes better. My motto is practice makes better, because all of us, even those of us that have done a lot of tree ID for many years, can still get stumped. Sometimes the tree you're looking at is a little different, just like people are different. So there might be, and that's how we got a lot of our cultivars that are now in the nursery trade. for example, at some point, flowering dogwood had a mutation and had pink flowers. And that was noticed. And someone said, hey, that's something we want to select for. We want to graft, we want to breed for that. And hey, now you can buy a pink flowering dogwood. But that was a natural sport of white dogwood that someone noticed and decided to propagate. So that happens constantly in the plant world. There might be a mutated tree or shrub that looks really different from what it actually is. So practice, practice, practice. And with that, I'm going to stop screen sharing and go back to, we're going to go to looking at, I'm going to mention the two books that were shown earlier. So since I'm going to be holding things up, depending on what view you have, you may want to have the view where active speaker is largest, because I'll hold things up and you can see them. But these two books are for sale from Virginia Department of Forestry. If you live near Charlottesville, or you go online and look at the several other offices where we actually sell the books over the counter, that is the cheapest way for you to get them. I think they're about $3.75, $4, something like that now. If you buy them both together, I think you get a discount. They're not very expensive, but if you order them online, we don't do our own web store. So the online sales are going through Department of Wildlife Resources, and they do add on shipping and handling fees. So they will cost you a good bit more if you buy them there. Over the counter is best. You can also download the whole thing for free. If you don't want to pay for any book, you can go onto the Department of Forestry website and download the entire book. You probably don't want to print it because it'll probably cost you more to print it than to just buy the book. But it is available for free if you want the text and the pictures of it. So we have one for trees and one for shrubs, and we hope that you'll be interested in getting them. There are a few other places in the state that sell them over the counter. I know the botanical garden or the arboretum at JMU sells them. The state arboretum, Blandy Farm up in extreme northern Virginia, sells them. There may be a couple of state parks that sell them as well. So you can just kind of, if you see them somewhere, great. If not, try to go on our website and look at our over-the-counter locations. So, okay, with that, if you have your dichotomous key, either pull it up online, or if you've printed it, I hope that you do, because I will read things to you, but if you've got it, it'll make it a lot easier. This is a single page key. I've made a lot of different keys for different parts of the state or for different particular samples of leaves. And I do one pagers because it's easier to start using a dichotomous key with a single page. In those two books I showed you, there are longer keys to a lot more species. So you can use those when you kind of get used to using a key. It takes a while to get through those. So a dichotomous key, dichotomy, as you know, probably the word dichotomy is a division. It's dividing something in two. And so a dichotomous key is always based on two choices. You will start with number one. You will read the two statements at number one, and you'll decide which of those statements best applies to the item that you're trying to identify. There are dichotomous keys to just about everything in the natural world. So once you learn the technique of using a key, you can easily use it to use a similar key to identify other things like insects or birds or seashells or rocks or whatever. So the technique is really important, and that's what I want people to take away from tonight. So I'm going to hold up something fairly simple that we saw earlier. Okay. And I'm going to put this like right in front of my face. Try to hold it still. So this time of year, leaves are just coming out. And so the stems are elongating from the tips, from the what's called the apical meristem. And so a lot of times the leaves look kind of jumbled together at this time of year. But if you can see the attachment of these leaves, that's going to be pretty important. You can probably see that these leaves have a certain type of attachment. So that's going to be important. You can see the blade of the leaf. I will hold one of them up. This is one of the ones that we saw earlier that we looked at characteristics. I'm actually going to pull one off. It's easier to hold up if I just pull one off. So we'll need to know that, and we'll need to know that attachment. And from there, I think we're going to try to keep us out together. So our choices at number 1 are the leaves are broad and flat, or the leaves are needle-like or scale-like. And I think everybody knows the answer to that. You don't even have to put it in the chat. This is not a needled tree. This is a broad flat leaf. So if you are looking at your key, if the leaves are broad and flat, you go to number 2. Had they been needle-like, we would have skipped right down to number 3. Okay, so the broad and flat leaves, we go to number 2, and we read both choices again. Okay, so the leaves are, this is where we have to look at the attachment. Are they opposite or are they alternate? So hopefully you can see this. This has little stipules that come out this time of year that I'm going to pull off because they get in the way of our looking at the attachment. Okay. Hopefully you can see that those leaves are attached alternately. So our 2 choices were, are they opposite each other on the stem, or are they alternating with each other along the stem? And in this case, they're alternate. So we're going to go to number 5. When we skip down to number 5, we have to know, is this a simple leaf or a compound leaf? And you all were great at identifying characteristics earlier, so I think you probably all know this is simple. Okay, so we're going with the simple leaf. We're going to go to number 9. Okay, when we get to 9, we have to know, does the leaf have no lobes and smooth edges, or it may have lobes or toothed edges, or both? So in this case, we're making a choice. If we had chosen 1, we would have the answer already, but we can see that this has lobes. Okay, so we're going to go to number 10. Okay, so we're going to look at whether those lobes are pointed or rounded. And I think you can see that they are pointed. Okay, so pointed lobes, we're going to go to 11. Okay, now do we want to know, does the leaf have 4 to 6 single pointed lobes, and they don't have bristles at the tips, or does each lobe have a bristle tipped point? Okay, you can't really see that this closely, but a bristle is like a tiny hair, little flexible hair. And I will tell you, this does not have bristles at the tips of those lobes. And it has 4, as we can see, 4 main lobes. Okay, so we now know what species this is. If you're looking at your paper, if this leaf has 4 to 6 single pointed lobes with no bristles at the tips, it's a yellow poplar, also called tulip poplar, tulip tree. There are a lot of common names. The scientific name is Liriodendron tulipifera. I don't expect you to remember that. There will not be a quiz. But that is the actual, if you do want to know what the real name of the tree is, the scientific name is the one that would be recognized all over the world by dendrologists who are familiar with this tree. Local names can be very different. I always call this yellow poplar, but a lot of people call it tulip poplar. A lot of people call it tulip tree. Locally, foresters just say poplar. And that's because this is the species of, this is what they mean by poplar. It's not in the poplar family though. So, but when foresters are talking about poplar, they don't mean things like white poplar and cottonwood and stuff. They mean this. So common names can trick you. And the actual real name is the species name that might be hard to pronounce. Okay, so oh, I'm seeing a chat here that says some people call it catface tree, and that's true. If you look at a usually a middle-aged yellow poplar, it has sort of these lines that come down from the branch attachments that are pretty distinctive on the overall tree itself. So yeah, I can see why they might call it that. This tree, incidentally, is in bloom right now. If you go out on trails and you find these big yellow flowers with a beautiful orange throat, that is a yellow poplar flower. And that's where it got the name tulip tree, partially because the shape of the leaf is sort of like a tulip in cross section, but also because the flower is somewhat tulip-like and really pretty. So you often don't see them because this tree shoots straight for the sky. It's very shade intolerant, and it grows in cutovers or very open situations where it gets full sun. So they grow really fast and really straight, and usually the flowers are way, way, way up there. So I usually find them lying on the trail, like maybe, they may have broken off or squirrel might have clipped them off or something. And they're just really pretty, but not often seen. And they're really important to bees as well. Okay, we are going to, now, I'm going to ask, we said this was I think we said a 1 hour presentation. Do we need to cut off at 1 hour, or what is your preference? I'm asking Courtney or Betty.
Yeah. I think if people feel like they need to leave, they should, certainly shouldn't feel bad if they have to go, but Absolutely. Anyone who can, we're getting a lot of keep goings in the chat. So I think there are people who are able to stay and want to stay.
All right, good.
I think we should just make sure that anybody who does leave will still be included in the drawings for the things, because it was included in just the hours. So anybody who was here for the hours still included in all that stuff.
So so we do know who the winners are, and if at the end they aren't here, we will send them emails and let them know that they were lucky.
Okay. Well, I will say for anybody who's getting ready to drop off right now, I'll probably stay another 10 minutes or so. And we'll try to look through some of the leaves you might have in your hands right now with your key. But if you are dropping off now, please use this key. Try the leaves that you collected or some leaves in your yard, preferably like the edge of your yard, edge of the woods, not trees that have been specimen planted, because they could come from anywhere. But this works for a lot of really common trees around here. And so you might be able to key your species out now that you know how to use a key. We're going to do one more, at least this one more. Okay, I'm going to hold this up at a distance. And so I'm going to ask, someone could put it in the chat, like first come, first serve. Is this a broad flat leaf or a needle and scale like leaf? Broad and flat. Yes, I see it. Okay, broad and flat is correct. So we are going again to number 2. In this case, you may not be able to see this because the points of leaf attachment are actually here on the stem. So these are actually alternate but they are very close together because May is a tricky time. You know, these things are just expanding, and sometimes they look all jammed together, but I will tell you this is alternate. So we're going to number 5. And when we get to 5, we have to know if this is compound or simple. And I will tell you that this is one leaf. So it is compound, yes. And as you can see, the leaf stem, very flexible. So even though it might look like it's got opposite leaves here, these are leaflets. And it's a very flexible stem. Okay, so this is compound. We're going to number 7. We need to know if the leaflets are smooth edged or not. And you may not be able to see this, but look really, really closely. It has teeth. That's right. Definitely has teeth. So the leaflets have tiny teeth along the edges, and we're going to number 8. Now we have to count the leaflets. So I'll do it for you since I can see them all. 2, 4, 6, 8, 10, 12, 14, looks like 15, 14 or 15 in this case. Okay, so this is, where does it fall in? Black walnut or a hickory? It's a walnut, yes. This is black walnut. This is one of those native Virginia trees that you probably know the wood if you, and you know the nuts. The nuts look like little brains, but when they're on the tree all throughout the summer, they're in these big green, like somewhere between a golf ball and tennis ball size, big green husk that falls off, and it's very brown, and was actually used to, this can be used to make a dye, a very dark brown dye. Black walnut wood is also a very rich brown. Oftentimes walnuts will be hollowed out inside, so they may not be much good for wood, but they are great for den trees, for lots of wildlife, and of course produce food for wildlife. Black walnuts are they're differently flavored a little bit than English walnuts. Kind of hard to get out the meat because those little brain looking nuts are hard to get into and hard to pick out, but a lot of people really like black walnuts as a kind of a slightly different flavor. So yeah, so that's black walnut. So what I would like you all to do now, if you have a leaf or a twig and you have this key, I want you to try keying out something you have. And it may be a species you already know, but that's the cool thing about keys. I always make people use the key anyway, even if you know what the species is, because that just verifies that you know the technique and that you can read detailed characteristics and look at your leaf and see why it fits each of these characteristics. That's way more important than just memorizing a list of species. So I don't know if we can tell how many of these folks have a leaf with them. If you do, key one out yourself and put it in the chat. If you don't, let's see, I will do one more.
Bring in quick.
Oh, somebody's got a black gum, which is actually, black gum is kind of my favorite tree. And that is the one that I showed you earlier that looks like a generic leaf. It's just an oval leaf, but they turn the most beautiful red in the fall, and they make these little berries that are great for wildlife. And they often when they get big, they hollow out, and black bears will nest in them, and just all sorts of cool things about black gum. Also, black gum scientific name is Nyssa sylvatica, which is beautiful to me. So I just saw somebody popped up and said that they just identified their Virginia pine after 27 years. So yay, that's great. And yeah, I see some people are not sure what they have, and it may not be on the key. You may have grabbed something that isn't on this key, which is fine. And again, if you get one of these books, or there are other books that have keys as well, there are some online keys. Virginia Tech has some great, their dendrology program has some online keys that you can try out that will go to a lot more species level than this one-page key. So if you're not getting yours from this key, go to, I should put that, I'm going to try to put that in the chat. I'm just going to put, I'm going to just put what you should Google because I don't know the actual, if you Google tree fact sheets, you can get to a one of the really good resources that Virginia Tech has. But if you Google just Virginia Tech dendrology, there's a place where you can go through an online key to leaves. So there. So those are some things to Google. All right. So somebody has a question. Let's see. I'm now looking at the chat. So I'm going to see if
what invasive trees would you recommend removing for the health of the forest?
Great question. I love that. Okay.
Questions.
All right. Number one, tree of heaven, Ailanthus altissima. Take those out, and you can't just cut them down. This is an unfortunate instance where you have to use a herbicide. Because if you just cut down tree of heaven, you'll get 10 more in its place. It will root sprout like crazy if it's cut down. So it's kind of like, what is it, the hydra? You lop off its arms and more come back. It's like that. So you can look up how to do this, but you can actually do sort of you can cut the tree down and then paint around the outside edge of the stump with something like Garlon or even Roundup, I think might work, but I know Garlon works. And do that immediately. And then that chemical will it's not going to get into the environment. It's going to be taken directly into that tree's roots and will kill it from the roots. You can also do a hack and squirt method, which involves taking a hatchet and just hacking a frill around the trunk, and you can squirt that chemical into those cuts. And that will also result in some uptake of the chemical. And that way you're actually getting rid of it. Other invasive trees that are less of a concern, but they're more locally a concern. I've seen them be really bad in some forests, would be Paulownia tomentosa, also called princess tree. That's one that can be a problem because it makes so very many seeds. Mimosa is one that in some areas can be locally problematic. As far as trees go, Ailanthus is the big one, the tree of heaven. And we have a ton of invasive shrubs, which is a presentation for a whole other time. But I would say shrubs are probably more of a problem in most of our woods, followed closely by vines. After tree of heaven, of course, tree of heaven is the worst tree we've got. So it's the biggest problem, and yeah, if you can get rid of it, please do. I see some people have definitely identified their trees, and that's great. And we're getting ready to close, but were there other questions in the chat that we needed to address? This is doing this as a virtual presentation. It leaves a lot to be desired. It's great if you can come out in person and do a tree walk with someone who knows what they're doing. The Charlottesville area tree stewards and maybe tree steward groups in other parts of the state do periodic walks that the public can come to. I do them sometimes. Your local forester might do them sometimes. So if you get a chance to go on a tree walk, there is nothing like going out with somebody who can show you and pass things around, and you can look at the actual tree itself. So this is, hopefully gave you a good start and made you interested in wanting to learn more about tree ID. It gave you some basics, and maybe you can get out there and start learning your trees and take a walk. And yeah, so that's all I have.
Great. Thank you. Thank you so much. That was really helpful, and hopefully soon we'll be back to doing things in person, and
Excellent.
maybe we can twist your arm to take us on a walk outside.
Yeah, I've been doing some already, so yeah.
Oh, great, great.
We can
And
definitely
before everyone goes, I wanted to let you know who won the raffle prizes. So I'll start with the 5 people who won the forestry books, and we will contact these 5 and figure out the best way to get the books to them. If you live somewhere near me, I might just drop them at your house, and if you don't, we'll mail them to you. But the winners are Helen Gregory, Robert Jennings, Kathy Mock, Deborah Fischetti, and Marlene Mandel. So congratulations, guys. You'll be able to get practice right away with identifying trees. And then the grand prize, which is the night at Meadowlark Ridge, was won by Noah Flood. So congratulations, Noah, and we'll also contact you about how to go about planning your adventure to Meadowlark Ridge. So, and thanks everybody for coming.
Thank you, Ellen, very much for joining us and for doing this for us.